Welcome to my channel. Today, we're improving our English while exploring the life of Sir Isaac Newton, the genius who discovered gravity and revolutionized science. As you listen, pay attention to new words, sentence structures, and pronunciation to enhance your English skills. Learning through stories and biographies helps you understand vocabulary and context, making English easier and more fun. So, stay with us till the end to improve your English naturally while uncovering the fascinating journey of one of history's greatest scientists. Biography of Sir Isaac Newton. Chapter 1. Early Life. Isaac Newton was born on January 4, 1643, in Woolsthorpe, England. His father, also named Isaac Newton, passed away 3 months before he was born. His mother, Hannah Ayscough, remarried when Isaac was just 3 years old, leaving him to be raised by his grandmother. As a child, Isaac was not very social and spent most of his time alone, working on his studies and experiments. Newton attended the King's School in Grantham, where he showed an interest in mathematics and science. After finishing his schooling, he went to Cambridge University in 1661. At Cambridge, Newton studied mathematics, physics, and astronomy. He spent many hours reading the works of earlier scientists like Galileo, Kepler, and Descartes, which inspired his interest in understanding how the universe works. At Cambridge, Newton's brilliance became apparent. He was known for his intense focus and curiosity. He often studied on his own, exploring mathematical ideas and scientific theories. During the time of the Great Plague in 1665, when the university closed, Newton returned to his family home in Woolsthorpe. It was during this time that he made many of his most important discoveries. Chapter 2. Discovering Gravity. One of Isaac Newton's most famous discoveries was the law of gravity. According to the legend, Newton came up with the idea of gravity after watching an apple fall from a tree in his garden. This simple observation led him to ask why objects always fall straight down. And from there, he began to develop his theory of gravity. Newton concluded that every object in the universe attracts every other object with a force. The strength of this force depends on the mass of the objects and the distance between them. This was the beginning of Newton's work on the law of universal gravitation, which was published in his famous book, Philosophiae Naturalis Principia Mathematica, or Principia, in 1687. This law explained not only why objects fall to the ground, but also how planets move around the sun. Newton's theory showed that the same force that makes an apple fall also governs the movement of the planets. His ideas changed the way scientists thought about the universe and laid the foundation for modern physics. Chapter 3. Work on Optics. Isaac Newton was also a pioneer in the field of optics, the study of light. He became interested in light while still a student at Cambridge. He experimented with prisms and discovered that white light is made up of many colors, which can be separated by a prism. This was a groundbreaking discovery, as it was previously believed that white light was pure and unchangeable. Newton also explained that the different colors of light are part of a spectrum and that each color bends at a different angle when passing through a prism. He used this to create a theory of color and light, which was later developed into the science of optics. Newton's work on light helped explain how colors appear and how light behaves when it interacts with different materials. In 1704, Newton published a book called Optics, in which he outlined his discoveries about light and color. His work on optics laid the groundwork for later developments in the field, including the understanding of how light behaves in lenses and mirrors. His theories in this area made him one of the most important figures in the study of light. Chapter 4. Laws of Motion. Isaac Newton is also famous for developing the 3 laws of motion, which describe how objects move. These laws are still used today to explain everything from the motion of planets to the movement of cars on the road. The first law states that an object will stay at rest or continue moving in a straight line unless acted upon by an external force. This is known as the law of inertia. The second law explains that the force acting on an object is equal to its mass times its acceleration, often written as FLMA. The third law states that for every action, there is an equal and opposite reaction. These three laws of motion were crucial to understanding how things move, and they provided the foundation for later developments in mechanics. Newton's laws helped explain not only everyday experiences, such as why a car accelerates when you press the gas pedal, but also the motions of the planets and the moon. Chapter 5. The Principia. Isaac Newton's most famous work is his book, Philosophiae Naturalis Principia Mathematica, usually just called the Principia. In this book, Newton explained his theories on gravity, motion, and the laws that govern the natural world. The Principia was published in 1687, and it became one of the most important works in the history of science. The book presented a mathematical framework that described the motion of objects both on Earth and in space. Newton's work in the Principia not only explained how planets orbit the sun, but also provided the mathematical tools that later scientists used to calculate the movements of objects in space. The Principia was a breakthrough in science because it unified many previously separate ideas about the universe into one comprehensive theory. The impact of the Principia was enormous. It changed how scientists viewed the universe, and it remained the dominant scientific theory for centuries. The book helped lay the foundation for classical mechanics and remained an important reference for future generations of scientists. Chapter 6. Later Life and Work. After publishing the Principia, Isaac Newton continued to work on various scientific topics. He became the president of the Royal Society in 1703 and served in this role for over 2 decades. During his time with the Royal Society, he worked on many issues related to science and mathematics, often engaging in debates with other prominent scientists. Newton also spent time researching alchemy, a mystical and philosophical field of study that sought to turn base metals into gold. Though alchemy was not considered a scientific field at the time, Newton believed it could lead to important discoveries. However, his work in alchemy was not as successful or influential as his other scientific contributions. In his later years, Newton's health declined, but he remained active in science. He was knighted by Queen Anne in 1705, which made him Sir Isaac Newton. He passed away on March 31, 1727, at the age of 84. His legacy, however, continues to influence the fields of physics, mathematics, and astronomy to this day. Chapter 7. Newton's Influence on Science. Isaac Newton's contributions to science are immense and far-reaching. His laws of motion and universal gravitation formed the foundation for classical mechanics, which was used to explain the motion of objects for centuries. His work in optics also led to advancements in the study of light and color, shaping modern physics. Newton's discoveries were essential in the development of many fields, including astronomy and engineering. His ideas helped explain the motions of the planets, the tides, and the paths of comets. They also allowed later scientists like Albert Einstein and Carl Sagan to build on his work and further our understanding of the universe. Newton is often regarded as one of the most influential scientists in history. His theories and discoveries transformed the way we think about the natural world and established a new era of scientific progress. He is often referred to as one of the fathers of modern science. Chapter 8. Newton's Legacy in Mathematics. In addition to his work in physics, Isaac Newton made important contributions to mathematics. He developed calculus, a branch of mathematics that is still used today in many fields, from physics to economics. Newton's calculus helped explain how things change over time and provided a tool for solving complex problems in science and engineering. Though the German mathematician Gottfried Wilhelm Leibniz also independently developed calculus around the same time, Newton is often credited with its invention. The development of calculus allowed scientists to make more accurate predictions about the movement of planets, the behavior of objects, and other natural phenomena. Newton's contributions to mathematics were so important that they are still taught in schools and universities around the world. His work laid the groundwork for future advancements in mathematical theory and opened the door for new fields of study, such as differential equations and mathematical physics. Chapter 9. Controversies and Rivalries. Throughout his life, Isaac Newton was involved in several controversies and rivalries. One of the most well-known rivalries was with the German mathematician Gottfried Wilhelm Leibniz. Both men claimed to have invented calculus, and their disagreements over priority led to a bitter feud between them and their followers. Newton was also known for his involvement in disputes with other scientists. He had conflicts with fellow members of the Royal Society, including Robert Hooke and John Flamsteed. These rivalries often centered around issues of credit for discoveries and disagreements over scientific ideas. Despite these conflicts, Newton's work remained highly influential, and his contributions to science were ultimately recognized and celebrated by the scientific community. His ability to think critically and challenge established ideas made him a key figure in the development of modern science. Chapter 10. Conclusion. Isaac Newton is considered one of the most brilliant and influential scientists in history. His discoveries in physics, mathematics, and optics have had a lasting impact on the way we understand the world. His laws of motion and universal gravitation provided the foundation for modern physics, and his development of calculus revolutionized mathematics. Newton's work changed how we view the universe, from the movement of the planets to the behavior of light. His contributions to science have shaped our understanding of the natural world and continue to inspire scientists and thinkers today. Isaac Newton's legacy is a reminder of the power of curiosity, perseverance, and the pursuit of knowledge. His discoveries continue to guide and inspire scientific progress, and he remains one of the most important figures in the history of science.